physics video. Comments mostly, I think. Might be some other subjects, I don't know. See how things go. Anyway, so Bob Hicks. Gary, I understand your argument that photons don't interact with other photons. Right? What I don't get is how red photons with a given frequency and green photons with a higher frequency combine to make yellow photons. Probably should have used a different color than yellow. Anyway, with a frequency midway between the two. Yellow ones are never made. It never happens. So it's like the speed argument. You know, two things pass each other going 30 miles an hour. Looks like 60, but nothing's going 60 miles an hour. Same thing with photons. The colors are only mixed in your brain. So your brain says red plus blue equals purple. There's no purple photons. So that's the simple explanation. They're not combined anything other than your brain combines them and says it creates the synthetic colors. So the only real colors would be the three, but they're not really colors. They're just frequencies. So the range of frequencies from like 400 to 600, is red. From 600 to, well, that would be too high. So do it by 75 each, not 100. So red would be like 350 to 500, and 500 to 750 would be yellow or green, and then blue would be 750 to 800 or something, or 900. That kind, whatever the exact numbers are. And your brain has just categorized those as being colors. They're not really colors in the real world. They're just a range of frequencies in the real world. But they can be interpreted to synthesize another color. So there's no white light. There's just your brain synthesizing the colors of the energy it receives, the frequencies. So they're never really mixed. They don't create a real ton that travels as a white photon. There's no white photons. There's only photons at these specific frequencies, and then those categories we call primary colors, but they're not really colors. Our brain just converts them into colors, if I can say it that way. But there is no such thing. There's only there's only the real frequency. The real frequencies can be loosely categorized and understood to be colors, the clump of frequencies, but there are no real colors. Okay. Totem of Solam. I don't like that name much. Matter is just a word for categories of particles that have mass. So I'm going to argue that that's not true. That matter bits and force bits are categorizable as very different, distinct properties. So the force bits are the ones going the speed of light. The matter bits are the ones that only move based on an imbalance that's created inside of them. And specifically, electrons and protons don't have perpetual motion. So they'll always resort to balance unless they're perpetually fueled or pushed by some force. So unless they're pushed by something that keeps pushing them, they won't keep moving. And it's only the big matter bits, the atoms, or the big nucleuses, that can create the rotation necessary, the right turn thing, to maintain their velocity. So mass has a distinction in the sense that only matter can have mass in 3 dimensions. And the force bits only have mass in the dimension they're traveling, the speed of light. Alright, mass is a property of certain particles. Particles is always kind of dangerous once you get past the electrons, the protons, and the neutrons. Calling an atom a particle is kind of messy. Anyway, mass is a property of certain particles, but not others. Okay, well, I'm going to argue that there's no such thing as anything that doesn't have mass. Mass is relevancy. Mass is existing. You can't exist if you don't have it. So I'd argue you're wrong. So, prove it. Show me one of your truly massless particles. Do you think that matter is made out of the same type of particles as light? Well, you're asking questions that, there's 500 videos in this channel. I mean, you want me to personally instruct you. There's a website linked in every one of these videos that describes the theory. So, I mean, this is just a fundamental question. And, I make videos called overview videos. I'll link to those on the they're indexed sort of, or they're in a clump together. You could just type in the word overview and they'll come up. And they're, some are older and I've updated since then, but the general theory will be explained. So yes, I think matter is made out of the same elements as the force. It's just that they're stuck together in matter. They don't fly apart. How many types of fundamental particles are there? So there's only one type. Well, there's two, polarizations. So there's two versions of force bit. Polarized X and polarized Y, red, blue, however you want to round, square. Two varieties of force bit. And when they're segregated, all the blues are separated from the reds, you have what's called magnetism. When one class of the polarization, square ones let's say, or blue ones, are at a frequency, we call it a photon, and when it's mixed we call it gravity. So there's only one force bit, comes in two varieties. I mean, it's only one force bit in the sense it has the same properties except for this distinction of polarization. So other than that, they're identical. They move the speed of light, and they just have a different orientation to the universe. If it could be said that way. I think it can be said that way because I just said it that way. Alright, so now he has a long comment here, so we'll deal with this. Yes, video might be short. Let's see how long this comment goes. But there are some other things I could talk about. Anyway, so everything in the universe is made of one thing. Yes. This one thing travels at the speed of light all the time. Yes. Okay, so matter gets formed when these particles get trapped in orbits. I'm not making arguments about how matter gets formed. It's not part of the theory. So, especially if you're going to say matter in the form of an electron, a proton, or a neutron. I don't claim they're created and destroyed routinely by the universe. I mean, neutrons are electrons and protons in my opinion, so neutrons can be made and destroyed. But I'm not too sure protons and electrons can. So, but it's really not the territory that this theory covers. I don't think any theory can, because frankly I don't think there's any evidence to defend a theory that attempts to. And the reason they get trapped in little orbits, so again I'm not accepting your premises of orbits in the sense of a traditional orbit based on its momentum and it's being pulled in by some kind of force. That's not the argument being made here. They're in arrangements to each other and they're moving in the sense that they're jiggling. But strictly speaking, I don't think there's anything like a classic orbit in atoms. Okay, so matter gets formed where these little particles get in orbits. No. And the reason they get trapped in little orbits is because they are being deflected 90 degrees. No. I mean, it's on the website. So I guess I'll show the picture of this again. But this section of the website details these atomic forces. Called the technicality section, actually. But and that the electrons and the protons function differently because this red and black force creates a different reaction. So the force bits that are, say, black, they'll deflect out of a proton at 90 degrees. They don't, and if they hit an electron, they don't deflect 90 degrees, they reflect. And so everything's a straight line push between the electrons. So that means the black force gets trapped between electrons, it creates high pressure. The red force gets trapped between protons, it creates a high pressure. But if the black force gets in between two protons, it leaks out at 90 degrees. And if a red force gets trapped between two electrons, it leaks out at 90 degrees. So I mean, it's not that complicated. It's not that hard to follow along. I mean, I've said it so many times. If you're not going to do any work at all here, then you're not going to be able to understand the theory. It takes a little bit of work on your part. It's physics. It's not going to be a crayon drawing. You got to participate a little bit. Anyway. Alright, so this statement, and the reason they get trapped in little orbits is because they are being deflected 90 degrees. No, that's just wrong. And for some reason they always bounce at 90 degrees. Wrong. The same direction, because otherwise there would be a 50-50 chance that the cycle would be destroyed every time the particle encounters a ton. Yeah, the fact that they could turn right, left, up, or down, they can go in 4 different directions. Obviously the forward and back is out of the question, depending on the interaction, the up and down. So it's always 4 different directions it could go. But that's the whole point of the point I'm making by emphasizing the fact that these objects don't have perpetual motion. And so they have a tendency, a bent or a lean in a direction often. That's why electrons don't travel particularly straight if on their own devices. They have to be forced to go straight, and it's because they do have that tendency to go left or right or zigzag. The point is in matter, they're in a rigid geometry of tension, so they can't go the wrong way technically because there's more pressure the wrong way. They're always going to go where there's the least pressure. So that's where the probability kicks in. So the laws of probability are going to dictate that once something's in that tension, that it's always going to turn right, because right's always going to be the direction of least resistance, so to speak. But I mean, it's a little complicated to give you the whole geometry that creates that extra pressure, but you can sort of understand it as if, like the Earth's pressure, it gets the gravity force has this 10 meters per second force that everything's going down at that rate. And what's happening is that is being converted by all the matter that can't move because it hits other matter. And that pressure becomes a kind of chemical pressure inside all of those atoms. So all those atoms get more pressure to go down, but they can't. They keep hitting other atoms. So you can sort of logically understand that an atom, say, halfway down, through the Earth, is under intense pressure, and if a little bit inside of it, if something was moving it in a forward direction, you could sort of understand that it's going to have more pressure above it than below it, and that it's going to tend to move, if it's going to move, in a down direction rather than an up direction, because there's going to be more pressure above it than below it. Okay, that's probably, I think that should be a sufficient explanation. Anyway, all right, let's label this property the orientation of a specific ton, and that makes sense. Well, I'm just saying it has a circumstantial condition, the conditions that it's moving in, where it is in the geometry of the atom, and then it has the condition of how it got there, how it got into the position it's in. Is it a foreigner or is it part of a stable mechanism? And depending on whether it's a foreign invader or part of the stable mechanism, it's going to dictate also different rules about how it's going to end up behaving. So it has an orientation, but its orientation can't overwhelm its circumstance. Okay, of course we must assume that the distribution of the orientation is random. Well, again, it's not. Nothing really. There's nothing random about the rockets on the space shuttle launching the space shuttle into space. Anything that happens doesn't happen just because of random. It happens because of a whole collection of causes and effects. So orientation is seldom going to be something you'd call random, because everything got to where it got by specific causes. I'd certainly argue that most stable conditions are balanced, and balanced is what you might call random. But like I said, even the most balanced substance on Earth is still jiggling within that realm. At any one moment, it's not in perfect balance. It's only an average over time that's balanced. And time can be a second, a year, 10,000 years. So anyway. Let's see, random with balance. Let's see. Although a singleton bounces, and let's get. Of course, we must assume the distribution of orientations is random. No, it isn't. So, although a singleton always bounces the same direction relative to its own motion, there is no way to predict which way a random ton will bounce with respect to the plane perpendicular to its direction vector. Well, I'm arguing that there is predictable circumstances. So if there is more pressure above it than below it, it's going to turn right than left. That kind of thing. On the other hand, I've heard you say that force bits cannot interact with each other. It doesn't matter. If they do, we probably couldn't perceive it. So I'm just saying, because it would be a net nothing interaction. So they may interact with each other. It's just that it would be of no consequence to our perception. But I'd certainly say the red bits would never interact with the red bits, and black bits don't interact with black bits, as a principle probably is true. Whether black bits interact with black bits, maybe they do. Whether red bits interact with red bits, maybe they do. But those are interactions we couldn't see. You can't see the consequence of them, because it's the same bit leaving as coming. So you can't tell. Going right through each other is the same as hitting each other, so the interaction is invisible. And the only ones that are visible are the ones where this thing is black and this thing is red, and when they hit each other, the red bit doesn't go this way, the red bit goes this way, and the black bit goes that way. You see? Okay, on the other hand, I've heard you say yes. Now, perhaps I'm confused. I think you're just, putsy. But I thought that there were only two types of tons, red and blue, yes, or black and white, or square and round, and that they bounce perpendicularly when they run into each other. No. What I've argued is that you theoretically could understand that the black bits are on one, like on lines in the universe, and the red bits are on a different line in the universe, so the two never mix. You could almost think of it that way. And the only way they can mix is when they hit matter. Because matter allows the two dimensions to crash into each other. So you can think of it as two different dimensions they're traveling in, and they can only crash when they hit the matter bit, is where the matter bit can do the black on red interaction. But it doesn't really matter. The only way they interact in a way that change is created, where black hits red, is in the matter, in the electron, or in the proton. Okay. Now, perhaps I'm confused, but I thought that they were only two types of tons, red and blue, and that they bounce perpendicular when they run into each other. Okay, so again, the black ones, when they hit an electron, don't leave perpendicularly. They reflect, essentially. Essentially, they're absorbed. Okay, this goes in and that goes out. They just exchange this direction for this direction. And then when a red bit hits a black electron, the red bit collides with a bit going horizontally, or this way, and that exchange is made. So it comes out perpendicularly. The red leaves perpendicularly, the black bit goes forward. It's on the website, right there. That image shows basically how you get the very low pressure between protons and electrons, because the red stuff is leaking out of the black thing, the black stuff leaks out of the red thing. There are other pictures, but you know, it's the red bit hits black bit, the red bit goes out the side. I guess I'll have to draw a picture of the black. There's the black one. So the black one hits, the red, the little forward bit goes in, the little going out bit goes out. That's the interaction. This is the force trapped between the electrons. As the electrons get closer, they create extra pressure. It's there. Okay. Alright, perpendicularly they run, okay, here we go. Perhaps I'm that they bounce perpendicular when they run into each other. So what happens when two tons of the same color collide? Well, as stated, the force bits, just for the sake of argument, I'm saying don't interact with each other. Now maybe they do, but you couldn't see it, so it doesn't matter. I'm just saying it's not relevant to the conversation. The relevant part is what happens when the force bit interacts with a matter bit. That's the physics. There's no physics to force on force, because we know there's no evidence that forces interact with each other. You have to have that they don't exist, essentially, unless there's matter for them to affect. If they're not affecting matter, they might as well not exist. Okay. Let's see, where was I? So what happens when two tons of the same color collide? Do they bounce at 180 degrees? Like I said, if a black force bit hits a black matter bit, so an electron bit hits an electron, it bounces, yes, a reflection. If it's the other way around, if it's a red bit of force and it hits an electron, it exchanges potential. That is, it gives away energy in some perpendicular direction, and it keeps the energy in the velocity direction, the direction of the momentum of the bit that hit it. Okay. Or pass through each other. So nothing passes through. So when force hits an electron, it either leaves perpendicularly or it creates forward momentum. Well, in both cases it creates a little forward momentum. That's also been explained over and over. But anyway. Okay, so magnetism is caused by the pressure of the ton forces. So again, they're force bits, but whatever. The pressure of the force bits acting on matter. Yes, segregated to specific polarizations. That is, so instead of hitting an electron with a bunch of black and red, you're hitting electrons with just black. So now it gets more momentum because the percentage of exchanges are all for this direction, for that direction. There's no perpendicular exchanges. Alright, and since magnetized matter deflects the blue tons at 180 degrees, no, 90 degrees. There's no 180 degrees, so wrong. And since magnetized matter deflects blue tons, so, you know, I don't know what to say. Magnetized matter, there's two poles to the magnet. One pole is doing one thing, it's proton heavy. One pole is electron heavy. And it really has to do with the perimeter of the magnet, really. It's where the force exits the matter will decide what it is, red or black. So that's the function. But anyway. Let's see. Pressure of the forces, and since magnetized matter deflects blue-tons at 180 degrees and red-tons at 90 degrees at one end and does the opposite at the other end. Well, it's true it does the opposite at the other end, so that's good. At least you got that part right. Thus, there's no pressure between magnets of opposite orientations, since the red-tons that are reflected at 180 degrees from the one end get sent out of the system by the second. Well, it's not necessarily getting sent out. Obviously, it's filtering. So you have to sort of understand that somewhere in the mechanism inside the magnet there's a lot of right turns and left turns. In the black end of the magnet, a lot of red force or whatever is getting turned, and in the red end a lot of the black force is getting turned to go out the other end. But whatever. No point in getting into the individual atomic interactions. But anyway. Okay, but then there is pressure on the outside of the magnet. Okay, so I don't know what that means. But then there is pressure on the outside of the magnets. Don't know what that means. Okay, so then why is magnetism so much stronger than gravity? Well, magnetism is repulsive, where gravity isn't any of that. So it's distinctively different. And I have explained this also. But I don't have a drawing of it on the website yet, which I have to do. But here's the argument. You can sort of understand it just as a probability argument. If you had the physical matter of the Earth and the physical matter of the Sun are not polarized. They're not magnets. Okay, they're all magnets of mixed, little atoms, and there's no coherent magnetism. So you have to understand that when the force leaves the Earth, the red and the black force, and the red and the black force are leaving the Sun, the odds of there being any energy getting trapped between electron and electron, okay, that's the repulsive pressure, remember? Okay, it's the repulsive pressure is just about how much distance. Distance creates pressure. So the key point you can see in this drawing over here, all right, is that when you move two electrons close to each other, there's a ton of extra force because of all these. You multiply the number of interactions, and interactions are force transmitters. So you only have, like, say, 6 interactions here, and you have like 70 interactions here. You get the picture that you have the same number of things, the same number of bits, but you have much more energy, in a sense, happening here than here. And so when the Earth and the Sun interact, it's not electron on electron. It's the laws of probability are that, say, when a little speck of force leaves the Earth, it's going to hit either an electron or a proton in the Sun. It's not going to hit just an electron and bounce off, and then hit another electron on the Earth, and then bounce off, and then hit another electron on the Sun. So all the repulsive energy will get dissipated, substantial percentage of it. Now it's not as obvious as two magnets, turned opposite poles, so they're not going to zoom into each other quite as fast, because not all the pressure is gone, because there will be sometimes when the little black bit hits another black bit on the Sun, and then the black bit reflects back to the Earth and it hits another black bit. So there's going to be some pressure, some repulsive pressure is still present. So it's the amount of repulsive pressure that still exists in gravity that's the trick, right? So it looks like it's attraction, but it's really the absence of the repulsion. It doesn't have full repulsion power, and so it's its weak repulsive power that is actually causing what appears to be the attraction. So, and clearly the leaking part would still be happening. So my point is there's no repulsive to compensate for the leakage of how many black bits hit the red bit and then leak out. So lots of leakage happening and not much repulsion, so therefore a force. Now comparing gravity to these other forces is kind of silly because it's actually the same force, okay? I mean, it's exactly the same energy force. And all you're really doing is trying to compare things that are really close to each other, like two electrons, and comparing it to things that are really far apart, like the sun and the earth. And it's the difference between things that are interacting without any inverse square law. So like if I put my two fingers together, like right here in the middle of my fingers, it's almost as if this was an infinite plane and this was an infinite plane, and there's no more inverse square law. You know, there won't be any divergence that'll weaken the force. But clearly with the earth and the sun, there's lots of force that won't get to the sun, and lots of force from the sun that won't get to the earth. So the inverse square law dilutes the force, but it's a powerful force. So there's no difference in the strength of the force. It's just the circumstantial difference where you've separated the electrons by millions of miles. Millions. And you have the inverse square law, which is just wiping out a ton of force. It's just leaking it into space. So, big difference. So it's silly to compare the two. But they're the same exact force, really. It's the same exact atomic function. It's just that there's no polarization with the Earth. Earth isn't a magnet. It's not a very. It's so incredibly weak as a magnet, you might as well not call it a magnet. And likewise with the sun. And so there's no polarization of the force. And there's the inverse square law, which the electrons and protons don't have as a problem. You can think of the electrons and the protons almost as squares. I mean, their interactions are direct, and there's no leakage in all of these other directions. Okay. I think I covered that. All right. Let's see. Well, I don't know. I just read from here, I guess. Okay, so the magnetism is caused by the pressure of the ton forces acting on the matter. And since the magnetized matter deflects tons 180, okay, we did that opposite end. Thus, there is no pressure between the magnets of opposite orientation, since the red tons are reflected 180 degrees from the ones that get sent out of the system in the second. I don't know what that means, but anyway. But then there is pressure on the outsides of the magnet. So he's talking about the energy on the outs. The two magnets are here, and he's talking about the pressure between the two magnets, and then the pressure from the outside world is pushing them together. Correct. Everything's pushed. There is no pull force anywhere in the system. You have to get pushed where you go. Nothing goes anywhere without a push. Okay, so then why is magnetism so much stronger than gravity? Okay, explain that. Which is caused by the external ton pressure. So again, it's not. The force is gravity is incredibly strong force when you think of what it's doing at those incredibly huge distances. So to call it a weak force, in my opinion, is just silly. The Earth isn't an electron, and yet the electrons are what's actually moving towards the sun. And it's the sun's electrons that are actually moving towards the Earth. That's how powerful that force is. Okay, is it because a much larger percentage of the tons are bouncing back and forth between the planets? No, it's exactly the opposite. There's so few bouncing back and forth. They're ending up leaking out perpendicularly. That's why there's less pressure. The repulsive pressure is leaking out. That's why gravity always appears as attraction, is because the force that's weakened is the repulsive force. Let's see. Stronger than gravity. I don't know why I can't. I should find a way where I can just mark where I was. Let's see. Bouncing back and forth between planets. No, which aren't magnetized. Yes, the fact that nothing's magnetized enough to be called magnetic. You know, I'm not saying there aren't magnetic poles. I'm just saying the amount of the mass that is magnetized is minute by comparison to the mass of the object. Whereas those same tons exit the middle of the magnetic system via the 90-degree rule. I'm just wondering how far you've thought through your system. Oh, fuck you. I mean, fuck you. You know, I don't know, what do you say to something like that? Yeah, I've spent 5 years developing this. And I've obviously spent quite a bit of time. I've got over 500 videos on this channel. Yeah, I've thought about it, shithead. Fuck. It's just such a stupidly rude thing to say. Who else would, you know, what other physics person would you say that to? You know, fuck you. So in the case of tons not interacting with matter, the ones you mean that are irrelevant to the existence of the universe. So if they don't interact with matter, they're nothing, essentially. It would seem that tons of the same color cannot interact. No, the ones of the same color can interact, and you're not going to be able to know they did. If this interaction takes no time, I just crashed into something perpendicularly, this one leaves this way, this one left this way, how could you tell the difference between that and them missing each other? How could you tell the difference? If it doesn't take any time, you couldn't tell the difference between a miss and a hit. Same with the head-on collision. Did they reflect? Did they go right through each other? Did they pass right by each other? It all looks exactly the same. Anyway, the only thing that makes the interactions look different is if one of them is a blue and one of them is a red. Then you can see, hey, red hit here and went that way. It changed its direction. Red's now going that way and blue's now going that way. So now you can tell that they didn't miss each other. They hit each other because red's going the wrong way. Get it? Did you think about it long enough yet? Let me know when you've thought about it long enough. Cunt. Anyway. On the other hand, when talking about magnetism, it seems they must have an elastic collision. This elastic crap is such a canard. It's just a useless bit of verbiage. Let's understand. Every interaction I'm claiming in the universe is conservative. That is, the energy goes somewhere. The movement doesn't get destroyed. You can't make a photon disappear. All right? You can't make a force bit stop going somewhere. It hits something, it bounces off, it goes through. Doesn't matter. It always moves. It always goes somewhere. It never, ever, ever, ever gets destroyed. So whether it's elastic or inelastic just really means, well, does the interaction happen real obviously, like the arrow just bounced off into each other? That's elastic. Or was it a little tiny bit more complicated where it hit here and then it went 90 degrees this way and then it went 90 degrees this way and then it went 90 degrees this way and then it went 90 degrees that way? You're going to call that inelastic because it took a circular path and ended up exactly at the same place. It just took time. So now it's inelastic. I mean, it's not a useful distinction. It just creates confusion. They're all conservational interactions. So the energy always goes to something. Friction, heat, conversion of matter, atomic reshaping. It always goes to some process. So which is it? What do you mean, which is it? So I'll read this again. There's no which is it in this tripe you just wrote. So in the case of tons interacting with matter, it would seem the tons of the same color cannot interact. So again, I don't agree with that. It seems that they can't interact. I've just pointed out how they get trapped. I mean, fundamental to the whole theory is them getting trapped between, you know, the electron bit and the electron bit. Where do I need them to interact with free force interacting with free force? There's no evidence that free forces interact with each other, that gravity interacts with gravity. Okay, the gravity force affects the gravity force. You always need a matter bit in there somewhere for the force bit to have any function. So your straw man presumption is what I'm going to call it. Yes, the force doesn't interact with force, but clearly, as I've pointed out, the most critical thing happening in the universe is the fact that the electron bits react differently to red force than black force, or however you want, square force versus round force. That it reacts differently, and the proton does exactly the same, reacting differently in exactly the opposite manner. On the other hand, when talking about magnetism, it seems you must have an elastic collision. So again, I just don't understand, fuck you, yeah. So which is it? Now, there isn't two things argued here, so I fuck you again. And why is there this contradiction in your system? Well, there is no contradiction in my system. You just don't want to pay enough attention to understand it. You didn't go to the website. You obviously probably haven't watched the overview videos, or enough of them. I mean, you could just argue, I don't understand, but you're making this argument that there's a contradiction. No, there's a problem with your understanding. You haven't paid enough attention. There's no contradiction in what I've argued as existing. Fucker. I just hate these people. This is fucking rude. It's fucking rude. Alright, so this has a little bit of the gravity thing here in this image, but it's a very simple description. I think I have some of it in text about how it's the electrons and the protons, and the induced acceleration, but I probably don't have the whole balance part in there yet. I'll have to read it again and see. I have to do more writing. I have to fix the magnetism thing because I still have the neutral bit in there. It must go. But this drawing's accurate, but the text isn't quite as good as the drawing. Well, especially these drawings aren't really. These are the ones that have to go. The text might be okay, but these little G things got to go. They don't belong there anymore. So anyway, so yeah, I gotta fix that. I just hate writing for whatever reason. I'll work on that. I'll try to schedule it for working. Yeah, that's what I'll do. Alright, so yeah, good. The software didn't crash. It's I really want to start supporting Linux, but there's every day I get like, oh hey, yeah, this is working really well. Something crashes in some putrid way, and you uninstall the software thing. You do this, you can't fix it. There's no way to even, you can't figure out a rational plan to figure out what's wrong. It doesn't give you any kind of useful information about how to, fix a crash problem. But anyway, it's not the end of the world, such. So how long have I been going on here? 43 minutes. Yeah, I could add a little bit more. So what I have been doing, I've been watching some of these BBC documentaries with the Iranian guy. Sorry, I just can't remember his name. And yeah, these are on the atom, so I'll try to get through some more of it. But it's like I want to play the whole thing all the way through, the 3 hours or whatever, just because there's just so many statements that are just such an example of how they just totally exaggerate the strength of their evidence and the strength of the conclusions they've drawn, the reasonableness of their confidence. And especially when they start talking about neutrons and, I mean, they really don't have a clue. I mean, they got it way wrong, in my opinion. So it's probably a good subject for me to go over. Oh, it's 2 mice because you have 2 mice because you have the wrong thing open. So anyway, yeah, so that's probably enough. So yeah, that's a subject for a future video. So much to do. I just can't. just so, I was just thinking about tons of experiments. So, I was thinking about the ferrocell again. So I really do want to dissect that, but I was thinking of, I have a bunch of little, not long fiber optic, whatever you call them, hairs. And I was thinking of it would probably be an interesting experiment to put a bunch of fiber optic lights around the ferrofluid cell thing, just to see if you get one of these little lines for every single fiber optic cable you connect, because it sort of looks that way. I mean, clearly the lines being created are relevant to the source LED lights that they use, and there's a line for every light. So if you had 100 little lights, around a slide, say, I was even thinking of using the microscope, with fiber optic cables producing the light. But anyway, I have to work on that. So I'm just saying, there's so many things that pop into my head, and I say, oh, I want to do that, and I want to do that, and I want to do that. But I need assistance to do it, because I don't really want to do it. I want to do the. It just takes so much time to set things up and do all, and I just don't have the. My brain is too busy mulling. It just seems a horrible distraction to have to do mechanical things. Strange, it's gotten that way. I used to like the downtime of just doing simple mechanical things, but now I just see it all as a time I'm wasting because I'm not thinking. It's just funny. Just, the funny course your life takes. Not where I thought I'd end up. It's a weird. That's what it is. Weird. But I guess it was going to inevitably be weird. Because, I mean, the way you try to imagine things happening is never going to be terribly realistic anyway. So, so it should seem weird, I guess. No matter what happened, it should seem weird. I don't think there's anything else I have to say.